Hello everybody, in this tutorial we will see scalar products, or which are also called the dot products. My name is Dr. Garuma Abdisa. The scalar product of vectors. Let us begin our discussion with two vectors A and B making an angle theta in between them, and the dot product of two vectors, any two given vectors A and B, is defined as A dot B equal to magnitude of A times magnitude of B times cosine of the angle between the two vectors. Assume that these are the components of the two given vectors A and B. Before we talk about the A dot B in a greater detail, first let us see the dot product between our standard unit vectors, namely I dot with I is equal to the magnitude of I times magnitude of I times the cosine of the angle between I and I. That is simply the positive x direction. It makes only 0 degrees with itself, so it becomes 1. Similarly, J dot with J or K dot with K is equal to 1, but I dot with J is equal to magnitude of I times magnitude of J times the angle between the I direction, which is the positive x direction, and the J, which is the positive y direction, is equal to 90 degrees, and the cosine of 90 is 0. For that very reason, I dot K and J dot K is always equal to 0, and the knowledge of what happens to the dot product of the standard unit vectors will help us to expand the dot product between any two given vectors A and B. So let us see that in a greater detail now. A dot with B is equal to magnitude of A times magnitude of B times the cosine of theta, and the component of the two given vectors A and B is given to be like this. So our intention is to find A dot B based on these component-wise multiplications. So A dot B is equal to AXI dot with BXI. Because I dot I is 1, we get AXBX. AXI dot with BYJ is clearly 0. AXI dot with BZK is also 0. AYJ dot with BXI is 0 because of the 90 degree between J and I. AYJ dot with BYJ is AYBY because J with J makes 0 degree and the cosine of 0 is 1. AYJ with BZK must be 0. AZK BXI makes 0 again, and AZK BYJ is again equal to 0, but now AZK with BZK must be AZBZ. So by eliminating the zeros, we get A dot B is equal to AXBX plus AYBY plus AZBZ. In order to determine the angle between the two given vectors, now it becomes very straightforward in that A dot B is defined to be the magnitude of the product of the two vectors times the cosine of the angle between the two vectors. And we have already found another important formula for A dot B, namely AXBX plus AYBY plus AZBZ. So by equating these two together, we can simply determine theta to be the cosine inverse of A dot B divided by the product of the magnitude of the two vectors, or possibly cos inverse of AXBX plus AYBY plus AZBZ divided by the product of the magnitude of the two vectors. So this will directly give us the angle between the two vectors, where the magnitudes are defined to be magnitude of A is the square of the sum of the components taken under the square root. The same applies for B, and that is basically the way we determine the angle between any two given vectors. Let us substantiate what we have discussed with some examples. And with direct substitution of everything we have into our formula, A dot B is AXBX plus AYBY plus AZBZ, and A dot B based on this formula will give us 242. And you have to also recognize that the dot product is a scalar, a pure number. Probably it may have some units. And the second problem is A is equal to 3i plus 7k, and B is equal to 10j plus 2k. Once again, we are required to find the dot product, that is A dot with B. And we first have to write by filling the remaining term is with 0, for example, 3i plus 7k, the missing term is j, so we write a as 3i plus 0j plus 7k, and in vector b, it begins with j, that is 10j plus 2k, the I term is missing, so we fill that first with 0i plus 10j plus 2k. If you are experienced enough to find this kind of problem, it doesn't matter if you don't even fill it with 0, but if you are a beginner learner of this course, what you have to do is go ahead by filling the missing terms with 0 so that it will keep you from making mistake. The coefficient of I from one of the vector with that of the other, the same applies for j and the k, and then you simply get a dot b to be 14 in this case. Another example is find the angle between a and b if the two vectors are a is 2i and b is 3i plus 3j. We go ahead solving this problem as theta is cosine inverse of a dot with b divided by the product of the magnitude of the two vectors, and a dot b is simply achieved using ax bx plus ay by plus az bz. And as I have told you earlier, vector a contains only the I term, and we have to fill the remaining terms with 0, that is 0j plus 0k. Vector b has only I and j, the k term is missing, so we fill it with 0k. So after doing so, we simply multiply the I of a with that of b, and so on for j and k. Then you simply get a dot b to be equal to 6. So the magnitude of vector a is now the square of individual components of the vector. In this case, it contains only 2i, that is the square of 2 plus the remaining terms are 0, and then you, after taking from the square root, you will get 2. Also, the magnitude of vector b is 3 root 2. So you directly substitute into our formula. Everything is there. A dot b is 6. Magnitude of a is 2, magnitude of b is 3 root 2. Then theta becomes the cosine inverse of 6 divided by 6 root 2 after simplification. The cosine inverse of root 2 over 2 becomes 45 degrees. So the angle between vector a and the vector b is just 45 degrees.